So in this video, we're going to start talking about a linked list. This is another type of list, and we've already dealt with arrays in general. We talked about those extensively. And of course, we also talked about the array list, and we've used that quite a bit in the code as well. So the linked list is another type of list. So just as a recap, you will need to know this because of the way that linked lists work. We've already seen that an array is an index list of items. So they can be primitive types, for example, ints, doubles, booleans, those types of things in the case of a normal array. Or of course, we can also use objects in the case of an array list and actually store them like that. So we've seen how to access individual elements by using an index. So the sixth item, for example, would be found at index position 5. So just as a quick recap, let's just look at this on the screen. You can see there that we've actually got an array on screen of 7 integers. So the index position to the left is the number that we use to access the particular value. So the first element, of course, we use index position 0. It grabs the value of 34. Index position 1 grabs the value of 18, so on and so forth. Now what happens internally, and this is important to get a good understanding of linked lists, is that Java will actually allocate 4 bytes of memory for each integer, because it needs up to that amount to be able to store the highest value integer. And we have talked about that in much earlier in the course about how that memory works. So you can see what happens there is that Java will try and do this contiguously. So you can see in this case what it's done is actually a formula that Java can use to actually figure out which address, which physical memory address to use to grab the value. So what it can do quite simply, it can look at the base address. This is actually for the first element in the array. So this would be index position 0. So you can actually use that formula, and what it can actually do is calculate the actual address based on that. So in other words, looking at the base address, which in this case is 100, plus 4 times the index number. So for example, if we want to get access to the actual third index position, so we would actually we'd multiply the index position 3 by 4, because 4 bytes in each integer, so that's 3 times 4 is 12. We would add that to our base address, which was 100, which was the first element, and that would give us the answer of 112. And you can see on the screen there that index position 3, its value is 112. So that's how Java sort of handles things internally, and this type of thing works for primitive types much the same way. In the example of a double, for argument's sake, well, it uses up to 8 bytes of memory for each double because it needs that for floating point numbers. So the same formula would apply. We would actually still do the calculation, but instead of multiplying by 4 for 4 bytes for an integer, we'd multiply by 8, which is 8 bytes for a double. So that works fine for primitive types where you've got a known value and it's always going to be the same length. For example, an integer is always going to consume 4 bytes of memory. A double will always consume 8 bytes. But what about strings? Strings don't actually work the same, do they? Because strings, of course, can be a variable size. And this also applies in general to objects as well. So as you can see on the screen now, I'm going to switch to the next slide. What's actually happening here is that we've got the same index to the left-hand side, the same array. This time it's actually got strings instead of integers, and we've got the same number. And you can see that there's actually a calculation there. It's 8 bytes. So what's happening is that the memory that's being allocated in the array is actually itself 8 bytes, but that actually points to another location in memory where the string is. So consequently, by doing that, Java can actually keep a track of the actual strings that are in the array, and also the strings can each be a variable length. They can be different lengths because, of course, strings can be a variable length, unlike an integer, which has to be and always is 4 bytes. So you can see the important concept there. Array index position 0, which is at a memory location 100. It's got a string address of 1034, and then looking at the memory address of a position or the address of 1034, it's actually got the string value, in this case of Tim. And likewise, we looked at another one for argument's sake, index position 3. Well, that's got a string address of 1024, and that points to the hello world as a string. So that's what's happening internally. Now, if we actually printed that out, we actually went through and did a for loop and actually printed that out. The actual order that would come out is actually Tim, Australia, Java, hello world, done, array, and array list. Because, of course, it's actually going through the index positions from 0 to 6. So it's looking at the first one, pointing to 1034, Tim. Looking at the next one, index position 1, 1037, Australia. Looking at position 2, 1046 is the string address, and that's going to be Java, so on and so forth. So requesting the string at index position 3 causes Java to calculate the address of that item in the array. So it's 100 plus 3 times 8 bytes equals 124. That's just this location here. but it then actually uses the string address to actually find the actual string. So that's what's actually happening internally by Java automatically. It's not something you need to know too much about. The other thing to note is with all these strings over here to the right-hand side, once your program stops executing or it goes out of scope in some way, the variables are no longer needed, then there's this process called Java's garbage collection, which goes through automatically and frees up that memory. So it releases it so it can actually be used again. So that, again, has all been happening behind the scenes, and it's not something you need to worry about. And just the final point here to make is that the actual string addresses do not need to be contiguous. So in other words, you can see here that one of the string address here for index position 4 is actually address 4000, but some of the other ones have got completely different numbers. So the point here is that things can be completely different, and that's the way that it happens, and it's done internally by Java. So just as a sort of further understanding, let's go and just write some quick code to actually go through this. I've created a new project, linked list, so I'm going to create a new class called customer. And it's going to have two fields. I'm going to have a name and a value, a double I should say. Private string name, private double, we'll call that balance. Going to create a constructor, have both of the fields as constructors, and let's just create a getter and a setter for both, even though we probably won't use them, but we'll do that anyway just for simplicity. Very basic class, and you've seen that a number of times before. But let's go back to our main method now, and actually let's just create some code. So we're going to start off by actually creating a new instance of the class. I'm going to do customer equals new customer, Tim, and let's try a value of $54.96. Then let's create a second object for this customer. We'll call it another customer. Then let's set another customer equal to customer. So we're setting it to the customer class, to the first one, as you can see there. But then let's set the other customer class, the second one. Let's use the set balance method and change the actual balance to $12.18. And then just to confirm it, let's actually print out a message. Balance for customer and customer.getName is customer.getBalance. Now, before I execute that, what do you think will actually happen? Just as a recap, we've created a new object here, a new instance of the customer class, and we've assigned the value to $54.96. We then created a second customer class called another customer, another instance. Then we set the value of this second class to the first object, the first instance that we created. We then actually set the value of the actual balance field to $12.18 using the setter for the second class. But what we're doing here is we're actually printing out the value of the first class. So what do you actually think will happen here? What value should we get? Will we get to the value $54.96 or $12.18? Well, let's just run it and see, and then we'll talk about it. You can see what's actually happened here is we've actually got a balance of $12.18. And looking at that code, you might first be wondering, well, why has that happened? Because isn't this actually another class altogether? So why does changing the balance of this second class affect the first class? And this is an important point to understand because it relates to this memory. So what actually happens is when we actually do this assignment, another customer equals customer, what we were doing internally, Java was actually assigning the second customer class to point to the first class. So in other words, it just saved the memory address. It didn't create a separate class. So this is really important to understand what's working there. So as a result of that only saving the memory address, when we used the set balance command, what it actually did was it actually saved the value in this original location. So for all intents and purposes, there's only one class here. Customer class is the first class, and another customer, the second one that we created, is actually pointing to the first one. So consequently, when we use the set balance method on the second class, it actually updated the first class. And that's all because of how memory is used and allocated within Java. I'm going to close that now. So if Java doesn't let us use pointers, in other words, we can't actually point to these objects directly while we're discussing them, well, look, it's important to understand all this before we can understand what a linked list is and the advantages that it can give you over an array. So let's just consider some more code now. I'm going to create some code that creates a basic array list of integers. We'll call it int list equals new array list, like so. And let's add some values. Int list.add 1, int list.add 3, int list.add 4. Then we'll use for int I equals 0, I less than int list.size. And you've seen this a heap of times before. So we're just going to show the values. We'll put element I plus int list.getI. That's just going to show the output of each element in the array. Next, we'll actually add another one. So we'll add another entry, int list.add. But what we're going to do here is we're going to put 1, 2. And what that actually does is that's inserting the actual number, in this case the number 2, in index position 1. So in other words, it's going to add the number, starting the first element position was position 0, of course, which had the value of 1. We're using index position 1, which should store it immediately after the 1. So in other words, it's the second element, and we're storing the value of 2. So let's just confirm that that works, and we'll actually do a printout after that as well. So let's now run it. So what should happen is the first time we get 3 outputs, 3 entries that are in the array list, and the second time we should get 4 entries. So let's just run that. So you can see on the screen there, we've got element 0's got the value 1, 1's got the value of 3, 2's got the value of 4. The second time around, you can see that clearly this has been inserted. So what's actually happened is in order for that to be inserted, the other entries all had to be moved down. So the element position 2, the value of 3, and element position 3, with the value of 4, they had to be moved down to make space for this new entry. Now this is not a big deal in terms of computer processing time when we're dealing with a small array, as you can see on the screen here. We've got 3 or 4 elements. But when we actually start talking about an array containing thousands or perhaps millions of existing records or existing items, it's going to get a lot slower to process. In other words, there's a lot more work the computer has to do because there's just so many more records to process. And similarly, if you have to remove an item from an array, what actually has to happen is all the other items have to be moved up to fill the gap. So in other words, if we actually deleted this position, element 1, then elements 2 and 3 would have to be moved up to fill that space again. So you can see that there's a lot of manipulation by the computer required to actually do that. Now, that's not a problem for a small number of records, but when you start dealing with large numbers of records, it can quickly become overwhelming for the computer and it starts slowing it down and just starts using a lot of resources. So we've finally got to the stage now of talking about linked lists. Well, the linked list is an alternative to arrays, and it's really useful in some situations. And how it works is it actually stores the actual link to the next item in the list as well as the actual data. So hence the name linked list. So in other words, each element in the list actually holds a link to the item that follows it as well as the actual value you're wanting to actually store as well. So a good example of that is to go back and look at our lists that we talked about earlier. I'm going to go back on the screen and show that. So that's our original string list that we talked about. But if we go to the next screen, this is how a linked list works. So you can see in this case, the first element, which was the value Tim, which we had assigned a value of the memory address 1037, you can see that it now points to the next one, which is Australia, the value of Australia at position 1046. It then points to the next one, which is Java at position 1024, and so on and so forth. So if we created a linked list like this, we could literally iterate through the lists of items in it. We could start on the first one, and what our code would be doing is we'd be checking to see whether the link has got anything else attached to it. In other words, whether it's linking to anything. If it does, we'd pick up the string stored at the location and actually save that. So in that case, if we've got a linked list like this, we could literally iterate through the items in it. So you can see starting at position a memory address 1034, it has got a pointer to the value of Tim, which is actually at the different memory address. We then look to see whether there's something else that particular record, that entry is linked to, and we can actually follow that through the list. So you can see that Tim, effectively the entry Tim points to Australia, which points to Java, which points to Hello World, which points to Done, which points to Array, etc. Different completely to how an array list works. But as a further example, let's just say that we're looking at this linked list and it's got some values, as you can see there, and it's actually a list of places but perhaps you might want to visit when you're in Australia. In this case, you want to start at Sydney, you want to go to Melbourne, then go to Brisbane and Perth and so on, and ultimately end up in Darwin. But let's just say that after creating this list, you decided to add a visit to Alice Springs on the way to Melbourne. So what we need to do is insert Alice Springs after Sydney. Now with a traditional array, you'd actually have to move all the other cities down to make room for that, as you saw in the code we just showed on the screen. But with the linked list, it's actually a heck of a lot easier. In fact, all we would have to do is actually set Alice Springs, the actual Alice Springs link, if you will, to point to wherever Sydney was pointing to originally, which was Melbourne. And then we set Sydney to point to Alice Springs. So you can see that's a heck of a lot easier. No records have actually had to be moved down to make room for anything. All that's happened is we created a new entry, which is Alice Springs. We pointed Alice Springs to where Sydney used to point to, which was Melbourne. And then we set Sydney to point to Alice Springs. And therefore we can still sort of go through that list and get to all the records that way. And in a similar way, go to the next screen, we can actually remove entries the same way. So in this example, for example, if we decided not to visit Perth, and all you would need to do is just make Brisbane point to wherever Perth was originally pointing to, and that's literally all you need to do. So in this case, you can see that we've changed Brisbane, which was pointing to Perth, to point to Canberra. So we looked at Perth and figured out that, okay, Perth was pointing to Canberra. We changed Brisbane to point directly to Canberra. And again, that's a function of a linked list. Now, it's interesting to note here that Perth is still pointing to Canberra, but because nothing is now referring to Perth anymore, because Brisbane is now referring to Canberra, the object will be automatically destroyed by Java during its garbage collection. So in other words, it'll figure out that this is no longer being used, this is Perth I'm talking about, and remove that automatically. So that's really the idea of a linked list. So I'm going to stop the video here. In the next video, we'll actually create some code. We'll actually create a linked list in Java code and go through this example so you can understand it from a code perspective. So I'll see you in that next video.